Hey folks, my name is Ravish and welcome back to another video in the series of DevOps real-time interviews. Now, we have a profile with us today. So this person is having around 3+ years of experience in IT and 2+ years of experience in DevOps and cloud-related services. So I've concentrated this interview around on 3 topics. First would be your Docker, second would be your Kubernetes, and third would be your Terraform. So these are the main topics that I've covered. A few questions here and there, real-time scenarios, and that would be all for this interview. All right, so if you're new over here, please do hit the subscribe button because that would really support me to create more content like this. And if you're watching this video on any YouTube short or Instagram or Telegram or anywhere else, make sure to check out the pinned comment or the description section. And one more thing, if you find any difficulties in understanding the language, please make sure to switch on the subtitles so that you can understand them well. So without further ado, let's get started. Great. Okay, so let's start with the application. So can you just explain me what type of application you guys are deploying right now?
Okay, so we basically deploy microservices. Yeah, it's a Java application. I've worked in Java application. I'm also working with React. Yeah, so I have worked a lot with React, okay, Node, with Java. I've also worked with Python and PHP. Yeah, but currently we are using microservices basically based on Java for backend, React for frontend.
Okay, so it's a microservices based application, right?
Yeah, microservices. Yeah.
Okay, and where do you deploy it?
It's deployed in Kubernetes. I am using Elastic Kubernetes Service in AWS. So I'm also using an ECS. Yeah, I'm using EKS. I'm also using ECS. Right, these two things we use them heavily actually.
Okay. So when you say microservices, like all of them are on Java or some of them are on React or some of them on Node.js? What kind of microservices?
Okay, so the backend service are purely on Java, right? But the front end is on React. So this is what I mean.
Okay.
The front end, the portals are on React, while the backend services are on Java.
Okay. So they are part of same pipeline or they have different pipelines?
Each of them have different jobs by itself. Each of them are separated by each of the microservices have a job on its own, right? They're separate pipelines.
What CI/CD tool you are using for these pipelines?
Okay, I am using Jenkins for the CI. I'm also using Argo CD. So I'm doing the GitOps process. So I'm combining Jenkins for CI, Argo CD for CD.
Okay, Argo CD for the deployment part, and for the CI part, you are using Jenkins, right?
I'm using Jenkins.
Okay.
Yeah.
So one job equal to one service. Am I correct?
Yes.
Okay, and your pipeline has multiple jobs, right?
Yes.
So how many jobs per pipeline?
Sorry, take it again.
You have a pipeline,
one service, right? Yes.
So how many jobs do we have in one pipeline?
How many jobs in one pipeline?
Yes. I mean, the pipeline that you are working on, how many jobs are there?
Represents a service. Let's say I have I have about 25 microservices for the backend alone. If I add the front end, I feel about 30 microservices, right? So each of these microservices has a job, right, on Jenkins. So about 30 jobs on Jenkins representing the microservices, right?
Okay, I understood. One job for one microservice, right?
Yes.
Okay, but this job is a part of some pipeline or not?
Is a part of some pipeline.
Okay, so that's what
it's a part of what?
Is a part of a pipeline or not? Or is it a standalone job?
It's a standalone job. The only thing I do is that maybe after build of each microservice, it will trigger a post-build action, maybe to build another job for the quality assurance, right? So each of the 30 microservices have a post-build action to trigger another job for quality assurance, right? Just to check quality assurance. So basically, see my design. Maybe from my design, you can understand. Maybe I can get your question, right?
Okay. Okay.
So each of my microservices.
Yeah, let's take it from the very basic. Let's say, explain me the CI/CD flow till production, from code check-in till production.
Okay. So see what I did. Let me start explanation, right? So in each of like I said, I have like 30 microservices. Let's say a microservice one. In my Jenkins job, microservice one, the job of microservice one, I use that same job to build for dev, stage, and production, right? It builds the one depending on what you have passed in your build parameters, on your build, in the build parameters, you have to select which one you want to build. Though most of these things are actually automated. Microservice one is used to build both dev, stage, QA, and prod of that particular microservice. So my flow is we are using GitHub, right? Once the application, each of the microservice gets to GitHub, Jenkins picks it up, builds it, tests it, and updates. So I'm using GitOps so that I have a manifest repository. So what Jenkins does is build, test, upload the image to ECR, and update the manifest repository. Argo CD is constantly looking at the manifest repository for any changes. Once there is a change, depending on what I have set, right? If it is the dev manifest file that changed, Argo CD will deploy the dev. Depending on whatever manifest that changes, Argo CD will take it and deploy. So basically, I'm using from GitHub, it picks up the application, it's picking it up depending on the branch you have meshed to. Assuming you have meshed to dev, yeah, it's automated actually to pick it up, build it, test it, upload to ECR, and update the dev manifest. Argo CD will pick it up and deploy it. This is my flow.
Okay, understood. Um,
Yeah.
so let's talk about a microservice architecture and the tools. So you have worked on Kubernetes, Docker, and Terraform, right?
Yes.
Okay. So now consider a scenario. Let's say you are deploying a microservice architecture. Okay.
Okay.
Your manager has given you a task in which you have to deploy a microservice architecture for a new project. Okay. How would
Okay.
you approach this using Docker, Kubernetes, and Terraform?
Simple. I'll start by planning. Okay, how many microservice, right? That will even help me to decide what kind of because in my Terraform, of course, I'm going to design my Terraform script. My Terraform script is I'm going to make it in modules, and I'm going to make it in different environments. So I have a particular folder structure I usually use. The modules are going to be separated. In my modules, I will be having things like IAM. I also have things like VPC, because my Terraform script is going to set up everything end to end. It will create the VPC, the whole networking. It's going to create the cluster. It's going to make it available.
Let's not talk about AWS right now. Just
Okay.
wanted to understand
Okay. So
Docker, Kubernetes, and Terraform.
okay. So after my planning, Terraform, I'm going to use Terraform to deploy the. I will write my Terraform script to deploy the environment, to set up the environment. Right. The environment.
Terraform script will not deploy, right? Terraform will create the environment.
Yeah, yeah. We create the environment. That's what I mean. Terraform will create the environment, the
Okay.
networking, the cluster itself, and all. Yes. So I'm going to use Terraform to create the environment. Yeah. Of course, Terraform will also create my EKS. So that is the environment. Terraform will also create the EKS, the Kubernetes. Now, when I have created the Kubernetes environment, I need to now deploy, right? Hello?
Yes, 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 I'm listening.
Yeah, yeah. When the environment is ready, of course, I'm going to start deploying my microservices. In my microservice deployment, I'm going to use Docker. I'm also going to use Helm charts, right?
Okay,
Hello?
how does this Docker and Helm chart play a role in this architecture?
Okay. So in my, I usually like Helm chart a lot. Even if I'm using a Go CD, even if I'm using traditional, I'm using Helm chart actually because that's what I'm going to use for the actual deployment. What do I mean? Now, when I have built the environment, right, I'm going to use, for my CI/CD, I'm going to use Jenkins. I'm going to use Argo CD. You can choose not to use Argo CD actually and use traditional DevOps practices where Jenkins can do the whole thing. But let me explain like this. I'm going to use Jenkins. I'm going to use Argo CD. Now, Jenkins is responsible for the build, right? When Jenkins have used Docker to build, upload to ECR, and update my manifest, now, Argo CD is, you can deploy a microservices to Argo CD in many options. Argo CD can ask you for the manifest file. Argo CD can ask you for the values file, right? So there are many methods in which Argo CD can use to deploy application to Kubernetes. You can use the manifest format or you can use the Helm format. If you're using the hem format, it's going to ask you for the values file. So basically, I am going to design my Argo CD to work with the hem format, right? In which when it is when the manifest folder has been updated, right? I have already set it up, so it is going to use my updated values file, right, to be able to deploy it. I can choose not to use hem and simply use manifest, right? Even if I'm not using Argo CD, I am still going to install hem inside Jenkins server and simply make Jenkins have access to the cluster, such that after the build and upload to ECR, Jenkins will run the command hem update install, whatever it is, right? In there. So I'm still using hem, even if I don't want to use Argo CD. So basically, I like to use hem for my actual deployment, right? Hem stands in between. Even if I'm using traditional DevOps, Jenkins runs hem install. If I'm using Argo CD is using the hem option because I have defined it to use the hem option. Yeah. So basically, using Terraform, I'm going to set up the environment. Using Docker together with hem, if I want to, I'm going to now start deploying the microservices. Remember, I've already seen my Docker file for each of the microservices. Yeah.
Okay. So let's talk a bit about log aggregation and analysis. Okay. So how would you implement log aggregation and analysis for a distributed application using Elastic Stack, like ELK,
Yeah.
right?
Okay.
Have you worked on
Yeah.
it?
Yeah. Sure.
Okay.
I use
Okay.
ELK a whole lot.
Perfect.
Okay.
So you
So
have to use ELK and Nginx. Okay. So how will you do it?
ELK and what?
Nginx.
What am I using Nginx here for now? Is it as a microservice or as a proxy?
I mean, it'll you can configure it to forward the logs, right?
Okay, log for okay. So basically, what I'm going to do, though we don't use, we have stopped using log stash. We're not using Fluent Bit, more like EFK actually,
Fluent D.
right? Yeah, Fluent Bit.
I have not heard about it, but I've heard about Fluent D. But okay, you can
Yeah,
explain
yeah,
about
yeah.
it.
Yeah, it's Fluent D actually. I still say Fluent D. So basically, it's the what we usually use is Elasticsearch, Logstash, and Kibana until there was a replacement for Logstash. Yeah, Fluent D actually. So we now call it EFK actually, if you want to
Okay.
anyway. So in place of Logstash, I'm using Fluentd. So basically, how I do set it up in my Kubernetes, I set these things up as with Helm chart. So I'm a very big fan of Helm charts. I use Helm a lot, right? Because it made my life so easy. It brings up my manifest and make everything so easy. It's just so perfect. Even if you want, you can use the same Helm chart to deploy for both dev, prod, whatever environment you need. So that is actually why I so much love. With a single Helm chart, I can deploy anything I want to deploy in any environment. I'm a big fan of Helm chart. So my Elasticsearch, I deployed it with Helm chart. My Fluentd, I'm going to deploy it with Helm chart. My Kibana is also going to be with Helm chart. So basically, I install these things. Helm install, you install your Helm. Fluent Bit, you install it. And then Kibana, you also install it, right? All these things have configuration files. Your Fluent Bit, you've already told it where the Kibana is. Your Kibana, you already told it the URL of your Fluent Bit. So in my Fluent Bit or Kibana, these ones are accessible via a URL, right? It depends on whatever you're using. Depends on I usually use ingress, right? Because Kibana, of course, is going to have a valid URL. I am going to define the ingress part of it. Also, Elasticsearch will also have an ingress part of it, but Fluent Bit is not actually accessible. You don't need to access that one, so it doesn't have Fluent Bit. So basically, I install these three things with mchat. In their values file, you have already defined values and told him, okay, this is where Kibana is, this is URL to Kibana, it works like Prometheus and Grafana. In Grafana, you need to tell it the URL of Prometheus for them to be able to work together, right? The same way that Elasticsearch and Kibana is working, right? You need to tell it, okay, Kibana, this is Fluent Bit. You need to be able to tell it that via your configurations.
I don't know, how would be the flow? Like, can you just explain me the flow between this your ELK stash or EFK stash, whatever you use?
Okay, Fluent Bit. Okay, Fluent Bit basically is actually to collect the logs from these microservices, right? In Fluent Bit configuration is where you're going to define, okay, I have microservice, device microservice, you need to pick it. So if you didn't define this thing in Fluent Bit configuration, It's going to pick anything it sees inside any container running inside the cluster. It will be giving you the logs. Let me take it again. So Fluent Bit is actually responsible for picking the logs, right? It's responsible for picking up the logs,
Mm-hmm.
right? Elasticsearch, sorry, Kibana is used to visualize this thing. Kibana is where you're going to visualize and see the actual logs. Elasticsearch basically help you to query the logs, to search through the logs, right? So Fluent Bit is responsible to pick up these logs from all your services running inside the cluster. These logs are made available in Kibana. If you can go to Kibana, you're going to see the display and however it is, you're going to see it there. Elasticsearch actually help you to search through these logs. You can search per microservice. Now um, you can fine tune your Fluent Bit, right? Because if you leave Fluent Bit without fine tuning it, it's going to pick all whatever no whatever pod is running inside the cluster. It's going to pick it up. Let's say you have, for instance, you have microservice 1, 2, 3, 4, and this is what you need actually. You also have some other things running in the cluster. Let's see, Prometheus, Grafana, and any other third-party service that is running. If you didn't fine-tune Fluent Bit, it's going to be picking all the logs from all the pods running inside the cluster. And I don't think that is what you want. That's not usually what I want. I basically want it to give me the application itself, maybe the microservice 1, 2, 3, 4. I'm concerned just the microservice. Leave out my other things like a metric server and all. Right. So basically, I fine tune my logs inside Fluent Bit. What does Fluent Bit do to actually collect these logs from the log directory of my containers? I visualize it and see all the logs in Kibana. This Kibana is what the developers need. The URL to Kibana, that is what they need. Inside Kibana, Elasticsearch actually help you to search through the logs depending on what you're looking for.
Okay. Okay.
Yeah.
So you worked on this Amazon managed blockchain. What you're doing in this Amazon managed blockchain?
What?
Amazon managed
Blockchain.
blockchain. You have
Blockchain.
mentioned, yeah, mentioned in your profile. You have mentioned.
I don't think that is my.
I
Can
mean,
you
I
write
don't
it
know.
out?
You have
I don't think that.
mentioned Amazon managed. If you don't know, that's okay. I'll move on to some other topic.
No. Maybe that was a mistake or I misspelled something. Amazon managed blockchain. I
Yeah.
have not worked on anything like
Okay,
that.
no
No, no,
problem.
no.
No problem.
Maybe that was a mistake on you. Can you share me the line of what I said there? Maybe copy that, share me on chat. Let me
No,
see.
exactly. You have written Amazon managed blockchain, but that's okay. I mean, it's totally fine if you've not worked on it. That's the
Check the profile again. Is that my name? Chimoke Cyprian.
yes, Chinwoike. Yeah, that's
Amazon
not
managed blockchain. Blockchain. What was I trying to write? In what company did I write that?
not company, but
Just to
in your
make sure.
skills actually. So when
Blockchain.
yeah, but it's okay. I mean, let's not talk about it.
No. I don't think I maybe I will check my CV again. I did not know what that came from.
No problem. Let's talk about Docker. Okay. So let's start from the very basics. Okay. How do you think Docker differs from traditional virtualization?
Docker what?
How do you
How do I
think?
think what?
How do you think that Docker differs from traditional virtualization?
Okay, how Docker differs from traditional installation?
Virtualization.
Okay, Docker give you a specialized
Did you
environment,
understand
right?
the
It
question?
gives maybe take it again. How Docker differs from virtualization? Is it?
Yes.
Okay. So Docker is more like a miniaturized, right? And it gives you a secluded environment, right? It gives you an environment on your own. Let's say, for instance, if you are installing, it works perfect. If you understand the Python virtual environment, that's exactly how Docker works, right? It's more like a miniaturized environment. It gives you to run a particular service itself. You can have this miniaturized environment 20 of them in one of your virtual machine or in one of your systems, right? So basically, Docker help you to give you most of the content of an OS, but in a miniaturized format, right? So it's different in the sense that it can require very minimal resource to run, right? Because it's quite miniaturized, right? It's also different because you're not running it on the bare metal. You can remove it now, reinstall it, right? And the Docker can actually die, and you can bring it up again, right? So it's basically give you a miniaturized environment that you can control and permutate the exact way you want.
Okay.
Basically, all the content of an OS, but miniaturized. Yeah.
And what about
But for your
virtualization?
virtualization, yeah, it also gives you an OS, but then it doesn't give you that advantage of easily manipulating it. Yeah, and I know you can virtualization actually you can terminate the whole virtual machine and bring it up, but not as very simple as Docker. And some virtualization, you actually need more resource to start it up because sometimes you are dealing with the entire OS, not the miniaturized format, right? If you go down here, they start talking about hypervisor and the whole thing, but I'm just giving kind of layman side of the whole thing. Yeah, so basically, it's virtualization still give you the entire OS, but it might not give you that opportunity of using um, the minute resource as possible, right?
Okay.
It's yeah.
How do you think Docker image differs from Docker container?
Okay, Docker con sorry, take Docker image from Docker. Okay, Docker container is a running image, right? It's more like a running when you take this image and run it, it becomes a container. The container can be stopped, it can be running, but basically, in a nutshell, a container is a running image, right?
And what is this Docker image?
A Docker image is a miniature. Okay, okay. A Docker image is simply I can call it a miniaturized OS, right? A Docker
So
image can be a miniaturized image,
can you
a miniaturized
apart
OS.
from using this word miniature, can you use any other word? Because whole of the conversation is happening on this
Okay,
word miniature. Any other word apart from this?
so that is basically what Docker is. Okay,
Yeah, but
Docker
like
image.
you can explain
Okay,
things in
Docker
other
image
way
is
as
more
well,
like an
right?
OS. Okay, Docker image is more like an OS running a particular, maybe running maybe should I use microservice? Maybe running a single microservice. That doesn't mean you can't run two inside it. There can be two containers when you run a particular image anyway. But then the most times we run only one inside a particular Docker image. Docker image can simply be we can say is an OS actually. It's an OS because this OS you can install it more like you can start it up and it start running. When you take an OS and install, you can now use it. Docker image, you can bring it up and run it and log into it, and it gives you the Linux shell and the whole thing. So I can say that Docker image is actually an OS, right? An OS, it all depends. Maybe you have built your own configuration, whatever you have built inside it, whatever config you have done, it's still an OS. You can share it with anyone to run it and exactly see whatever you have done inside it. I would simply say it's an OS actually. You can share to everyone. You can share to anyone in the internet. Yeah, to use.
Okay. How do you persist
Yeah.
data in Docker containers?
How do you process data?
Persist, persistence, right? How do you persist data in Docker containers?
Process. Is that what you said? Process.
Persist, persist.
Persist. Okay. Yeah. Okay. So you use Docker volumes actually. Yeah. Number one, you can use Docker volume. Yeah. Number two, you can okay, you can say okay, send your data to an external source like a database, right? You can
Mhm.
send it to a external source like a database, or you can use Docker volumes. Basically, you can use Docker volume. You can assign an external volume to a Docker volume. Just passing the v command when you want to run it, it will actually persist that record so that when it fails, your data is still there. You can still start up a new one and your data is still there. So you use Docker volumes, or you can send your records to an external database.
Okay. So when we talk about a Docker container, how you can secure it? What are the best practices?
A Docker container has a number of best practices to secure it. So, number one, you're going to be using the Slim or Alpine images, right? When you use the Slim or Alpine, it gives you the best secured form of Docker image because it's not loading a lot of whole things. Yeah. So we prefer to use the Slim or the Alpine images primarily to reduce the image size and also for security reasons, for security purposes. So you can start your Docker by using Slim or Alpine to secure it. Another one is that you can actually scan your Docker image. Like in AWS, you can actually enable the scan by default, or you can use your own scan. You can use, I think Snike actually does that as well. So basically, on my own basic way, I use the Slim or Alpine. I also scan the Docker images. And maybe you should not run so many things inside your Docker. Some people, when I see their Docker file, they are doing yum install telnet, they are using yum install call. So many installations. Maybe you should reduce your installation inside your Docker image to exactly what you need, right? It will also help you, right? And then you should not pass sensitive data inside your Docker file. You can define them as environment variable and pick it from somewhere. And maybe save it somewhere else, and then during your run, it will pick it from there. You don't save sensitive or don't add sensitive arguments inside your Docker file. I think this are the much I know and I used to practice.
Okay. Okay. So you have worked on Terraform as well, right?
Yeah, I use Terraform.
Okay. So what are the services that you created in Terraform?
A number of them. Okay, I've created the VPC itself. I've created EKS. I've created EC2. I've created S3, ECS, Lambda.
Okay. Okay.
There are a number of them.
What is the difference between Terraform state and Terraform plan?
Terraform state. Terraform state gives you the state of the environment. It gives you exactly what is existing. It's not like the Terraform memory. It understands where exactly what has been installed and what is existing, right? Terraform plan is simply a command to do a dry run of Terraform, right? It's more like a dry run. Is works the same as apply, but then apply does the actual run, right? Terraform plan is simply a dry run. It looks through what you have, right? From the state, it understands which one is existing before, right? It will simply show you what is going to be applied, the new thing you're adding, right? It's going to show you the new thing you're adding, but will not actually put it there, right? It's basically to do a dry run of your Terraform. State is more like the memory to understand where Terraform is or where the state of your application to understand what is existing already.
Okay. So how do you think Terraform handles dependencies between the resources?
Dependencies within the resources.
Yes.
Okay, when one resource depends on another, yeah, there is a depend on flag where you
Mm-hmm.
can put. If your EC2 depend, of course, your EC2 will depend on your VPC. So your EC2 should not start until your VPC is deployed. We use the depend on flag, right? If you have resources that depends on each other, you can use the depends on flag. This is what I use actually to be able to know that okay, this person or this particular resource has to wait until this one is deployed before it now gets deployed. So I use the depend on flag provided by Terraform.
Okay. Okay. What is the purpose of this Terraform providers?
The purpose.
Of Terraform providers? Provider, you know, right?
Yeah, there are so many providers like AWS
Yes.
and Azure and so many of them. Yeah, it's basically need to direct Terraform on which on even though I have not really gone through that anymore. But I think it simply tells Terraform, right? If let's say if you define an Azure service and you're using AWS provider, of course it will flag it. Then you this provider does not have this particular service you have mentioned, right? So it basically tells the Terraform, okay, this is what you should look out for. Terraform is cloud agnostic. There are so many cloud platforms, so there needs to be a way to restrict it and to make it understand where whatever it is doing. I think it is using that Terraform provider to know exactly which because it understand all cloud platform, you need to tell it exactly or to restrict it to which one you should use at a particular instance.
Okay. So a lot of people say that Terraform is platform agnostic. Do you believe it's true?
It depends now on what our definition of cloud agnostic is. Yeah, of course.
I
You
mean,
can use
I
Terraform.
want to know your opinion. What do you think?
Okay, for me, if I go into details, yeah, oh, I think it is cloud agnostic. The only thing here is that if I'm doing maybe resource AWS S3, right? I can't do AWS S3 when I'm using Azure. I'm going to use maybe Azure Bucket or whatever, right? I'm going to be it's even though I can use Terraform in AWS, I can use it in Azure. However, the resources are not the same. You need to understand Azure's resources. You need to understand AWS resources. For me, that is the only thing that I can say that is it actually truly agnostic in the real sense or in every sense or in all aspects. The only thing that there are resources, you need to be able to call that particular resource. You can't go and be using AWS S3 and be using it and you want to use Azure provider, it will reject it. Right? So for me, then again, if you understand how to use out of AWS, Azure will be a walkover for you. In that sense, you can say, okay, cloud agnostic. But when you're defining resources and the whole of this thing, they are not actually because you need to balance it, right? I will still go with them that it is cloud agnostic, yeah, of course, because if you understand this, you definitely understand this. It won't take you any time. However, you need to pay attention to the resources when you are creating them.
Okay, okay. So you were
Yeah.
talking about Terraform modules, right? Why do we need Terraform modules, and can you give me an example for it?
And so you don't do repetitions, right? You can define your module and then you call it up multiple times. We do this mostly because, of course, you're going to deploy your dev, stage, quality assurance, and production. The modules remains the same for all of them, right? So what I do, I have my modules. It remains the same for all the services and all the environments I'm setting up. Then inside the environment, you can now, from your local.tf file, you can now define, okay, assuming I have an EC2 instance, I have defined it as a module. In my dev environment, I am using a T3 micro. In my production, I may be using a C5 large, right? So in those specific definitions I usually do it in my local.tf file. Yeah, but the block of code that actually deploys an EC2 remains as a module. So basically help you to avoid repetition and help you to you don't necessarily need to repetition mostly. Keep your code clean and simple, and then you don't you have a one-off place to look at when you want to change your module. You have a one-off place to look at, not going through all the Terraform. So basically, it helps us to avoid repetition and it keeps code clean and simple.
Okay, can you give me an example of it?
Yeah, like I said, I use it in my environment. Let's assuming I want to start up an EC2, right? This EC2 instance, I need one for dev, I need one for QA, I need one for stage, I need one for prod. Simple. I will write my EC2 module, right, and put it in the module folder, right? In my dev, so I have a particular folder structure where I have life, I have modules, right? Inside modules, I have my modules, all my modules, say an EC2 module. Excuse me. Yeah. So inside my modules, I have an EC2 module. Then inside my life, I have my dev folder. I have my stage folder. I have my QA folder. I have my production folder. Right. Inside my dev folder, I have my Terraform files, main.tf, local.tf, provider or terraform.tf. Right. Depending on whatever I want inside there. Right. Then in my, let's say for my dev, in my main, right? In my main.tf, I am now calling this particular module, right? There is a keyword for that. You call the module slash your forward slash until you get to it, right? Basically putting the path, right? You need to call the module the source. You need to put the path of where it can get your module folder, right? And then you can put your, of course, in your inside of module, you have put everything is var, right? Your instance type var, you have var everything, yeah. So in your main.tf, you're now calling up this var, right? But what I do is that inside my main.tf, that my var, I will still not put the exact value. I will put local dot because I'm going to define it in my local directory, right? So all this thing is just to I make sure all configuration are done in the local.tf. my main.tf is simply to call it up and use the value in the main.tf, but relying on this module, right? This is exactly what I do. So my EC2 is in my module folder. I am calling it up inside the inside my dev main.tf, right? But the values, I'm extracting it from the local.tf in that same dev folder, right? So this way, everything is clean and organized. Even if you're a new person, I don't have to go through the code to show you how it is done. By mere looking at the folder structure, you understand how everything is being placed, right?
Okay. Okay. So
Yeah.
when we talk about sensitive data, such as API keys, secrets, how do you manage them securely in Terraform?
Sorry, take it again. How do I manage secrets, right?
Secrets, APIs, keys in Terraform.
Okay, so it all depends, yeah. If it is microservice specific, I manage them in secret manager and in my secret manager, yeah. If it is sometimes more okay, in fact, most times I use Terraform Cloud. So in Terraform Cloud, you define your secrets and everything. It is there in Terraform Cloud. You
And
can define it as a
if we are
variable.
not using Terraform Cloud, then
Like if you're not using Terraform Cloud, it's simple. Now, if in your laptop you can actually define it to pick the secrets from your laptop, right? Because you have done your AWS configure and installed your secret on your laptop. So you can define your Terraform to pick the secret from your laptop. Or you can make it, so most times I don't allow my teammates to make any change in Terraform on their laptop, right? You can't do Terraform apply on your laptop. What we do is you make your changes, you confirm it is fine, you make a PR, right? When we get it merged, it will not be applied. You get the picture. So basically, I'm using version control for my Terraform. So you get it merged, and it gets applied. So in that my whatever I'm using, if I'm using GitHub Action, I'm going to define my secret there, and my secret remains in GitHub, right? If I am using that particular approach, I don't know if you get. So basically, on my side, I am using Terraform Cloud. I'm going to use Terraform secrets or secret variables to do that. Or if I am using GitHub, if I'm using version control, I will define my secrets in GitHub, right? So because basically you're not running Terraform apply in your laptop. All you do is make your changes, do the plan. Is it fine? Then you push your code. Somebody in the team will review and get it merged. Once it is merged, it is been applied. Maybe using GitHub Action or any pipeline you want it to use. Yeah, so I can define my secret there in GitHub Action. If you want to use Jenkins still, you can define your secret in Jenkins. The bottom line is I am not defining secret inside inside the Terraform files. I'm either defining it inside my laptop or in GitHub Action or in Jenkins or in Terraform Cloud.
okay, okay. How do you think Terraform handles environment-specific configurations?
Yeah, environment specific. Okay, if you talk about Terraform Cloud, you actually have environments. Yeah, your stage environment is not the same as, so it uses workspaces to do that. I use Terraform Cloud a lot actually. That's why I know this. So Terraform it uses workspaces. It will tell you which of the workspace are you working on. You can say dev workspace. So like that, it will use it to differentiate your environment, right? Or if you're not using Terraform Cloud, you can use the workspaces inside your Terraform has a workspace
Mm-hmm.
command. Terraform workspaces, right? So whenever you want to work on dev, you switch to the dev workspace and switch to the stage workspace or QA workspace, right? So you have the ability to switch to any of the workspace you're working on. And what Terraform Cloud simply does is to do it for you. You don't need to switch. Just merge your code and get it pushed. Just push your code and get it merged. Terraform Cloud already understands which of the environment because you have set it during your initial definition. So basically, yeah, from Terraform Cloud, Terraform don't use workspaces to do it for you. In your laptop, you can switch to each individual workspace. It also depends again. You can use S3 different S3 buckets, yeah, to differentiate your state files. You can still use the same S3 bucket, but in DynamoDB, Terraform understands if you're using workspaces and you're using the same backend. If you're using workspaces, Terraform will place it better for you. The backend bucket may be the same thing, but inside your DynamoDB table, you will see the difference, right? So there are multiple options for you. You can use Terraform Cloud. You can use different S3 buckets. or you can use them Terraform Workspaces on your laptop.
Okay. Um, let's talk about a scenario in which you
Yeah,
might use Kubernetes operators.
Kubernetes operator. Sorry, I can't really wrap my head around on what operator. Can you give me one of them so I understand what the question is? Kubernetes
No, no. My
operator.
question is you. I'm asking you a scenario in which you might want to use Kubernetes operators. Do you know what is Kubernetes operators?
No.
Okay. Okay, then we can skip it, but I'll explain. So basically,
Okay. Okay.
Kubernetes operators are used to automate the management of complex stateful application on Kubernetes. Okay, so they encapsulate operational knowledge and the best practices into software that can manage the entire life cycle of an application. If you talk
Okay.
about an example, in a scenario where you need to deploy and manage a distributed database like Elasticsearch or Kafka on Kubernetes, you can use Kubernetes operator tailored for that specific database. So what will happen is the operator would handle tasks such as provisioning storage, configuring replicas, handling the backups, and performing upgrades all in a Kubernetes native way. So that's, you can study more about it. So this is a basic scenario.
I will definitely have to because I don't think I've
Okay, no problem.
really searched. Yeah.
Um, what is the purpose of a service in Kubernetes?
Server to server.
Purpose of
Take it
service
again.
in Kubernetes.
Performance. Sorry, I didn't understand. Performance service.
Purpose. What is the purpose of service in Kubernetes, and
Oh, okay, okay.
how does
Okay,
it
okay, yeah, yeah,
facilitate? Let me speak first.
yeah. Okay.
What is the purpose of
Sorry.
service in Kubernetes, and how does it facilitate communication between pods?
Okay. Service is important in Kubernetes because it gives you a static gateway to a particular pod, right? Because pods are not stable, right? They can easily die and they can easily come up. So service is more like a gateway to reach a particular pod, right? Also, sometimes there can be more than one pod of the same microservice, let's say about 20 of them. So service is a singular gateway to each of these similar pods, right? And most time we'll have replica of pods, right? So service is basically a singular gateway. If a pod dies, the service does not die, it's remaining. It provides a static entry to a particular pod, right, or particular group of pods. So it is important in Kubernetes because number one, there can be several replicas of the same pod, right, and each of them will have a temporary private IP. You cannot be reaching each of them once. Just send your request to the service. Service will direct it to the next available pod of the on that group of pod. So it is important because it gives us a static gateway to a particular pod. It is stable, more stable than the pod, so that if a pod dies and changes IP when it comes up, you don't really need to go to your application and start changing the URL to your pod again. Your service is already defined. Service is there to provide a singular gateway to a particular pod or a group of similar pods.
So let's say there are two pods. Okay, how will service make a communication between both the pods?
Are these pods the same? Are they replicas or two different pods?
They are different.
So each of the pod have their own separate service, service one and service two, serving pod one and pod two. If a pod one wants to make a request to pod two, it's going to go through the service actually. So their communication is done through their service names. Right. I don't know, is that a question?
Yeah, I mean, do you know what is labels and selectors?
Yes.
What is the purpose of label and selectors?
So labels and selector is basically used, and you use it to more like direct the pod. So basically, you label a pod such that it's more like replicas. You're labeling sorry, I think I'm mixing things up in my head.
See, my question was how does a
Okay.
service facilitate communication between pods? Okay, service facilitate communication between pods using labels and selector. So basically, when a service is created, it selects pod based on the labels and then routes the traffic to the using load balancing mechanism. This allowed
Sorry.
pods to communicate with each other within the cluster regardless of their dynamic IP address. So this is what I was looking at.
Sorry. I think I'm rushing now. Sorry.
No
I'm
problem.
I'm kind of a bit tense now. It's okay. Yeah, sure. It's fine.
How much is your experience in Kubernetes?
Yeah, it's since I started DevOps actually.
So like,
Okay, I didn't start as an intern. I spent 1 year as an intern. After my internship, I began using Kubernetes. It's about 4 years now.
okay, okay. Okay,
Yeah.
so how do you handle rollbacks in Kubernetes?
It depends on what I'm rolling back now. So basically that is one of the reason I'm using Argo CD. In my Argo CD, there are so many ways you can do a rollback. In fact, in your manifest file, what I do usually is that my manifest file or my manifest repository is a singular source of truth, right? Whatever update you have made there is what is going to be deployed inside the cluster. Just there are multiple ways. If a microservice you want to roll it back, you can actually edit the manifest file itself. You can go to the manifest and maybe if it is image tag 40 you want to roll back to, just maybe the existing or the current one is 41, you can make it 40. Immediately I go see that it is 40, it is going to go back, it is going to roll it back to the next microservice. You can also roll it back in Argo CD, but when you have rolled it back in Argo CD, you need to disable auto. You actually defined it there. Argo CD works in such a way that once it sees any update in the manifest repository, it's going to pull it up and deploy. So in Argo CD, you can roll it back there and tell it not to. Maybe you can disable. I don't know what they call it again, or you can disable more like an auto update, right? So two ways. You can go to the manifest and edit it yourself manually. Argo CD will redeploy the old version, or you can roll it back in Argo CD and disable, can't remember the name now, but it's more like disable auto update such that it won't try to look at the manifest file and update it again, right? You just remain at the one you rolled it back to until you say otherwise, actually. These are the two ways I do my rollback on microservices.
Okay. Can you explain the difference between a daemon set and a stateful set in Kubernetes?
Demonset is basically is basically a service, or more like if we want a particular pod to run in all the nodes. When we want a particular pod, say a monitoring or a logging pod to run in all the service, we use Demonset. Demonset enables us to have a particular version of the pod in each of the nodes. In each of the nodes. Excuse me. Stateful set, sorry, stateful set is used to deploy things like, even though we don't regularly use it, we want to deploy things like, that have states. Let's say you want to deploy a database inside the cluster, right? It's not a good practice actually. Whenever you're learning or whether you're doing anything in Kubernetes, they always advise you to your database should be external, right? Inside RDS or EFS or external storage. But if you insist on having things like database inside your cluster, you should use things like stateful sets. Stateful set helps you in such a way that when there are multiple instances of that particular service or microservice or application you have deployed, it the files or so basically why we don't stateful set came because we don't want to install database inside our Kubernetes cluster. Why? Because if I have two instances, I need to save a state like a
I
database.
lost you actually. Can you just
Oh,
repeat the stateful set? I lost you for about a minute.
oh, okay. So basically, I'm saying that stateful set is basically used to install or set up things that have a state, more like a database, right? If you use things, it is more like an opposite of deployment. If you use a deployment and there are multiple instances of that database, there will be data inconsistency because this particular service can write to this DB and that particular service can write to the other DB with data inconsistency. So to avoid this, and you want to deploy things like a DB inside the Kubernetes cluster, you're going to use a stateful set. Even though we don't basically use it all the time because such application or such things that have a state, we can store it in RDS or an external EBS or EFS, right? But if you insist on installing things like DB inside the Kubernetes cluster, it is done with stateful sets, not deployments as other microservices. This is my understanding of it.
Okay, okay. So you must have heard about Kubernetes namespaces, right?
Yeah.
Okay, so can you describe me a scenario where you might want to use Kubernetes namespace?
Okay. Let's say you have, I've actually used it, and let me tell you my own scenario. We have dev, QA, stage, and production, right? We want to have this four environment. We also want to save money. We want to save cost as well. So what I basically did is my dev and my QA are in the same cluster but different namespaces, right? That way I have, for each Kubernetes cluster you deploy, actually, there is a master node. There is a master somewhere hidden for you, but you can see there is a master. That master costs money, right? In order to save money on the master nodes, what I simply did is I had three clusters instead, three dev, stage, and prod. But inside my dev cluster, I have stage, I have dev and QA. But what I simply did was to use namespaces to differentiate them. Yeah, the QAs, the developer, they don't even know how the setup was done. I simply know that I did the whole setup, right? Yeah, so my dev is on the dev namespace and the quality assurance is in the QA namespace. They're in the same cluster but different namespaces. I use this exact scenario to differentiate the environments. I use
Okay.
namespace to differentiate the environment. Having two environment running in the same cluster with different namespaces.
Yeah, I mean, Kubernetes namespaces provide a way to divide cluster resources between multiple users or multiple teams. They are useful for isolating applications, enforcing resource
Yeah,
quotas, or organizing the deployment. We had a
yeah,
scenario in which we had a multi-tenant environment. Okay, so each tenant
okay,
has to have their own namespace so that we can deploy and manage the application independently without affecting any other tenant. So that was something
yes,
like dev
yes.
staging and production environment that you talked about. So yeah, that's one of that.
Okay, yes, yeah, actually, I can run them in the same cluster, but that is not what I want. Why? Because these environments are in different regions, are in different AWS accounts. So you can't, it becomes dicey when you want to run everything in the same cluster. As I said, okay, dev and QA should run in the same cluster, but different namespaces. Other ones can run in their individual environments. Yeah, so I'm also working with compliance, right? So you need to be able to balance this thing. Yeah, if they insist on saving, I can actually run everything in one cluster, but I will be going against compliance. So
Okay, okay. So this would be my last question for today. What do you understand by daemon sets in Kubernetes, and when should you use them?
Demonset is an application service that you use it when you want to have the same, when you have a particular version. Okay, when you want a pod to run in each of the nodes, right? You want a particular pod to run in all of the nodes. You're going to use the monset. We use it when we deploy things like monitoring. When you want to be monitoring each of the nodes, you can have the monitoring pod deployed in all of your worker nodes, right? So basically, daemon set is used to make sure that a particular pod is running in all of your nodes.
Okay, okay, okay.
Yeah.
Yeah, so basically, daemon set ensure that a copy of specific pod runs on all the subsets of nodes in a
Yes.
Kubernetes cluster. They're useful for
Yes.
deploying system daemons or monitoring agents that need to run on every node, right? You, if you want to do monitoring. Let's say for
Yeah.
an
Sure.
example, what we used is you can use it to deploy a logging agent like Fluent Bit we were talking about, right? Or
Yes.
a
Yes.
monitoring engine
Yes.
like Prometheus node exporter on every node so that
Yeah.
the cluster to collect node level
Yeah.
metrics
I
or
use it actually. Yeah. Sure.
okay, okay. Yeah, that's pretty much about it. I think I'm done.